This cigar box is an electrical truth machine. You might call it a primitive lie detector, inspired by Jevons's logical piano in the Oxford Museum of Science. I made it while an undergraduate studying greats, that's Latin, Greek, philosophy and ancient history at Merton College. That was in the 1950s. It works like this. Suppose there are two statements made. Statement P, which might be, it's raining, and statement Q, which might be, the streets are wet. And somebody makes the third statement, the streets are wet, implies it's raining. In other words, Q implies P. Well, suppose the streets are wet, but maybe because they've been washed and it's not actually raining. Now we want to test the implication Q implies P. I've turned the knob to Q implies P. Just there. The light is on, but if I turn the switches so that I've got the streets are wet but it's not raining, the light goes out. In other words, the implication is falsified by that combination. Actually, it's not falsified by other combinations. For example, the light still comes on if I move the switches around like that. It's only the one case where the streets are wet and it's not raining, where the implication fails. I could do another test of, shall we say, the statement that both P and Q are both true by turning the knob to P and Q, which is there, and when P is true and Q is true, the relationship P and Q lights up the light. But if I turn off either or both, the light remains stubbornly out. Only when they're both on does the light come on. The inside of the cigar box is very crude compared to Jevons's beautifully made logical piano. The wires to the light pass through the P and Q switches and also through 4 spring contacts touching a cocoa tin lid. The edge of the lid has strips of brown paper stuck to it in such a pattern that for every one of 16 rotational positions a different combination of 4 contacts is made. For example, on, off, off, off for P and Q, i.e. only true if both true. There's a close-up of the 4 contacts. The mathematical theory of such cyclical arrangements is deep, and I arrived at the pattern of brown paper strips by trial and error. Later in my career, which was, of course, in computers, I made use of the theory in connection with encryption and pseudo-random number generation. By the way, if you would like to contact me, I'm afraid I'm not on email, but if you write to Postmaster Jevonson, care of the 4th Plinth, Museum of the History of Science, Broad Street, Oxford, I'd be very happy to correspond with you. After the cigar box logic machine, which dealt with the propositional logical calculus, I became interested in how you could solve syllogisms electrically. This has to do with set theory, which was pioneered by Venn. Typically, a syllogism has two premises, for example, no Aryans are barbarians, some Christians are barbarians, and a conclusion. And the conclusion might be some Aryans are not Christians, or it might be some Christians are not Aryans. It's not always obvious which of the two is the correct conclusion, or whether both are or neither are. In this case, after a bit of thought, it's obvious that the correct conclusion is that some Christians are not Aryans. In the example I've just given, it's possible to draw a very useful diagram called a Venn diagram illustrating the situation. So you draw a circle representing Aryans and another circle representing barbarians and a third circle representing Christians. And when you look at the syllogism, no Aryans are barbarians means that you can cross out this area here. No Aryans exist in this area which is common to barbarians. The second premise was that some Christians are barbarians. In other words, we're trying to put a tick in this area here. We can't put it in there because it's been ruled out by the first premise, but we can put a tick in there. And now we consider the conclusion. The first conclusion was that some Aryans are not Christians. That's to say, we're asserting that it's allowable to put a tick in this area here. But that doesn't follow from the two premises. We haven't got a tick there. So the conclusion doesn't follow. The second possible conclusion is that some Christians are not Aryans. In other words, we're alleging that there's a tick somewhere in the box. Some Christians are not Aryans in here. That area there. And indeed, there is a tick. There isn't a tick there, but it's sufficient to notice that there's a tick implied by the two premises. And so, coming back to our original conclusion, some Christians are not Aryans. QED. In the Venn diagram, you can number the different areas, for example, 1, 2, 3, 4, 5, 6 and 7, and you can express the premises and conclusions in terms of propositions about whether particular areas have or have not got members. For example, no Aryans are barbarians would be that there are no members of the little set 2 and there are no members of the little set 7. And so you're converting set theory premises into the propositions which were covered by my first machine, the cigar box. Now that the syllogism is found to have 7 propositions, the problem is considerably bigger than the old cigar box. And with the cigar box, we had 2 to the power 2 to the power 2, where 2 was the number of propositions, P and Q. The streets are wet and it's raining, and that's equal to 16, which was the number of positions on the cocoa tin lid where you had brown paper or not. But with the syllogism you have 2 to the power 2 to the power 7, where 7 are the number of little areas on the Venn diagram. 2 to the power 7 is 128, so we've got 2 to the power 128, which is, well, very large, and would require a cocoa tin lid about the size of the Albert Hall to implement. So I had to use a different method. To make my syllogism logic machine, I got some graph paper and a sharp razor and some sellotape, and I made up 3 little booklets. One booklet covered the first premise, the second premise, and the last booklet, which has now been lost since it's 60 years ago or so, but when I made it, covered the conclusions. What I did was to take the 128 possible logical combinations of propositions and cut a little square in the graph paper if that particular combination was true for that particular premise. And I did that for both premises and the conclusion in such a way that if you put a premise on top of another premise on top of the conclusion and held it up to the light, and you could see through it in any place, it meant that 2 premises were true for a particular logical combination and the conclusion was false for that particular combination of premises, which meant that the syllogism was failed. I think it would be nice for me to demonstrate how this works by showing you some punch cards. After I left Oxford and was in the Royal Air Force, I worked in computing, and I found punch cards a good deal easier to manipulate than sharp razor blades and sellotape. Here are our premises again. No Aryans are barbarians. Some Christians are barbarians, and we want to know whether a conclusion, therefore, some Christians are not Aryans, follows. And what we do is to put the cards together into a little stack and then inspect the pattern of holes on the right hand side. If you can see through to the black in any position, that must mean that the conclusion fails. You can't see through, and therefore that particular conclusion is correct. But if I was to take away that conclusion and try the other conclusion, that some Aryans are not Christians, when I look at the right hand side, there is black showing through in several places, which shows that the syllogism fails. Thank you very much for your attention.